This is my intermediate algebra course. Today we're going to continue to learn how to graph quadratic expressions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In the previous class, we graphed quadratic expressions in vertex form that had irrational x-intercepts, and we graphed quadratic expressions in standard form that were easily factorable, and the coefficient of the x squared term was 1 or -1. In today's class, we're going to continue to graph quadratic expressions in standard form, but the coefficient of x squared is going to be a number other than 1 or -1. So let's get started. And I want you to take a screenshot of all this information. You probably already have pictures of these on your phone or on your computer, but if you don't want to go to the effort to access those, you can take a screenshot. And today this information is going to be particularly useful because, again, we're using standard form, but we're also going to refer to intercept form possibly. And also remember, in standard form, this number here is the y-intercept, because when you want to find the x-intercepts, you let y equal 0, and if you want to find the y-intercept, you let x equal 0, and if you let x equal 0, all these terms disappear and you're left with c. So c is always the y-intercept. That's useful information. As we did in the previous class, for these problems I want you to find the x-intercepts and the y-intercept and draw the line of symmetry and write its equation. And of course, the most important point, as always, of a parabola, a quadratic expression, is the vertex. Okay, so first we're going to label constants. Remember, those numbers are called a, b, and c in standard form. And at this point, we could change this to intercept form because it turns out that this expression is factorable. And we are going to factor it later on in this problem. But if we did that and we used m plus n over 2 as we did in the previous classes, we would end up with a complex fraction here. And I just prefer to use the standard form formula for finding the x value of the vertex, which is negative b over 2a, which you probably recognize from previous classes. So there's b, and then a is 3. And you're probably getting tired of me doing this, but I'm just going to be absolutely clear where these numbers come from by coloring them. And if you simplify that, you get 2/3. Now we're going to find the y value of the vertex by plugging in that 2/3 to the original equation. And just to be absolutely clear, we got that 2/3 from here. And at this point, we have to do quite a bit of arithmetic. And if you're rusty on this arithmetic, that's okay. But if you have never seen this arithmetic, that's not okay. That means that you probably didn't take my arithmetic course. Remember, arithmetic is a prerequisite for this course. Now, we don't have a lot of room on this particular problem, so I'm going to have to go ahead and skip a lot of steps here. But in the next problem, I'm going to show the steps in case you would like me to do that. Most teachers at the intermediate algebra level would not show this arithmetic. They just say, well, if you don't know it, tough. But I'm going to show you some steps. But here we have 4/3 minus 8/3. Again, I'm not showing the steps because we don't have room in this particular problem. And 4/3 minus 8/3 is negative 4/3. And this one we could just write as 3/3. So then we have negative 4/3 plus 3/3 is negative 1/3. So what that means is the vertex is 2/3 negative 1/3. And that is the first step of the problem. And I forgot to write Roman numeral 1 for the first step. We want to keep track of what we're doing here. Also, I forgot to write that we're finding the vertex. I want to title each step here. So first step is finding the vertex. All right. So Now the second step is we're going to find the y-intercept. And remember, in standard form, that's really easy to do. Of course, we're going to let x equal 0, and when we do that, we find that the y-intercept is, remember, use this principle here, the y-intercept in orange, you can see, is going to be 1, because we let x equal 0, and those terms here go away, and you're left with 1. So the y-intercept is 0, 1. Now step 3, we're going to find the x-intercepts. And to do that, of course, we're going to let y equal 0. Okay, and I'm going to copy that. We have 3, negative 4, 1. 3, negative 4, 1. I'm going to copy that down. Now, we could change this to intercept form, and we could see the intercepts, just by looking at intercept form. I'm not going to do it that way, but I'm just going to show you how you would do it if you wanted to use intercept form. It turns out that this expression is factorable. If it were not easily factorable, and by the way, every quadratic is factorable. It's just a matter of whether or not it's easily factorable. This is easily factorable. If it were not easily factorable, it would not be easy to put it in intercept form. But what we're going to do is we're going to go ahead and factor this expression. Now, in previous classes, we asked what two numbers multiply to 1 and add up to negative 4. But because we have a 3 here, that's going to complicate things. We're going to ask what two numbers multiply to 1, but those two numbers are not going to add up to negative 4 because the 3 is here. It complicates things. So what we have to do for this problem is we have to ask what two numbers multiply to 3, and that's obviously going to be 3 and 1, and the reason we need the x's is because we have x squared on that term. And we're going to ask what two numbers multiply to 1, and that's obviously 1 and 1. The problem is this is a negative number, so we need to change those positive ones to negative ones. Okay, and at this point you might say, oh, we're in intercept form. Well, actually we're not, because this number is here. Remember, intercept form is a times x minus m times x minus n equals y. There's no coefficient here on the x, you see. So we're technically not in intercept form. This number here is 1, but there's no number here. So what we have to do is factor out the 3. Now, we've done a lot of factoring in my classes, but we haven't done factoring that produces a fraction. So that might seem kind of weird. You might say, whoa, wait a second, how do we get the 1/3 there? Well, I'm taking this expression and factoring out a 3, and we get this. Now, to see why that works, go backwards, distribute. Use the distributive property. 3 times x is 3x, and 3 times negative 1/3 is negative 1. So that's why that works, and now it's in intercept form, and we can see the intercepts. And I just want to remind you that the reason that 1/3 and 1 are the intercepts is because if you plug in 1/3 here, it makes this entire expression 0. If you plug in 1, it makes this entire expression 0. And if the expression becomes 0, what does that mean? Well, it means y is 0. And that's exactly what we're trying to do when we find the x-intercepts. We're trying to let y be 0. But I'm not going to use this method. I'm actually going to go back, and in order to reinforce the idea of solving a quadratic equation by factoring, the way that we would do it in my beginning algebra course, and also to reinforce the idea that we're letting y equals 0 to find the x-intercepts, what I'm going to do is I'm going to go back and change the y value to 0 and just solve as I would, again with the typical quadratic equation that is a quadratic expression that's factorable. Now, be aware that we could solve using the quadratic formula. Negative x is equal to negative b plus or minus root b squared minus 4ac. Just plug in the numbers using 3 for a, negative 4 for b, and 1 for c. Or we could solve by completing the square. But because this expression is factorable, we're just going to factor. All right. Now, if this expression were, let's say this expression were x plus 4 times x minus 1, then we could just see that the solutions are x is equal to -4 or x is equal to 1. And we just jump from this step to this step. But I want you to be aware that technically, in order to show why that's true, you would have to say that x plus 4 is equal to 0 or x minus 1 is equal to 0, and then solve and say x is equal to 1 and x is equal to -4. You know, I don't make you show this intermediate step because it's just tedious. You know, it's just something that is kind of a you know, I don't want to make you do that. It's not really necessary. But the problem is, once you have an equation that where you get 3x minus 1, then students, they're not really sure how to find the x value here. A lot of students would say, oh, that this factor tells us that x can be 1. Well, no, that's not right because the 3 is there. So things get a little bit more complicated. So for that reason, I'm going to set these equal to 0 to show you, you know, how to find the answer. Again, whenever there's no coefficient there in any of these two factors, we don't do this. We just skip right to the answer. So 3x minus 1 is 0, or x minus 1 is 0. And again, the reason that we're setting these to 0 is because that's what makes the expression 0. It's very important to understand you have a factor here and you're multiplying by another number and you get 0. That means that the blue or the green has to be 0 because you're multiplying the blue with the green. Remember, whenever you multiply a number by 0, you get 0. That's what we're looking for, the purple 0. Okay, so either the blue has to be 0 or the green has to be 0. So that's where we got this. Okay, so now we solve to find the x value that makes the blue or the green 0, and that's how this works. So this is all stuff that we went over in my beginning algebra course. If you're rusty on it, then that's okay. We also, I think we reviewed this in this course, if I remember. Okay, so now we have our x-intercepts. Let's go ahead and plot those. So 1/3 0 and 1 0. And our vertex is 2/3 -1/3. So 2/3 -1/3 is about there. 2/3 -1/3. And our y-intercept is 1, 0, 1. And then we can just connect the dots. And of course we want to draw our line of symmetry. Okay, and we can say x is equal to 2/3. That's the equation of the line of symmetry. All right, I don't know if that line was exactly straight, but you get the point. On to the next problem. We're going to do one more of these before you try one on your own. So this is, again, standard form. We're dealing with standard form today. So let's label the constants. And just like I did before, I'm going to use -b over 2a. First step is to find the vertex. So -b over 2a. Plug in b. b is 7, and a is -2. So that's where I got those numbers. And then if you simplify that, you get 7 over 4. And it might be useful for graphing purposes to change that to 3/4. And if you're not sure how to change an improper fraction to a mixed number, you can just go to my arithmetic course and review that. So now we're going to plug in to find the y value of the vertex, and it's better to use the improper form of the fraction when you do this. It's just easier to do calculations with improper fractions than to use mixed numbers. And now I'm going to show more steps here. And I'm not going to do this for every problem. I'm just going to do this for this problem because I know that some students may need some review with the basic arithmetic at this level. But again, technically you should know the basic arithmetic. Most teachers would just expect you to know this without showing you any of the arithmetic. Now 7/4 squared, that means 7/4 times 7/4. That's what squaring means. And I'm just going to multiply these. And I can move this over a little bit. So now when you multiply fractions, you just multiply the numerator straight across. So 7 times 7 is 49. And the denominators you multiply straight across. So we have 4 times 4 is 16. And when you multiply a whole number by a fraction, again, you should already know all this stuff. You can just write the whole number as over 1, and you just do the same thing you did here. You just multiply straight across. 7 times 7 is 49. 4 times 1 is 4. So here we get 49 over 4, and then plus 4. Okay, and again, you're multiplying a whole number by a fraction, so negative 2 times 49 is negative 98. And we need to multiply both sides of this fraction by 4 to get a common denominator. We cannot add those fractions unless we get a common denominator. So 49 times 4 is 196. And now we have a common denominator. And I could write this 4 as over 1 and then change it to 16 over 4 by multiplying both sides of this fraction by 4. But I'm going to do it a slightly different way. So now we have a common denominator. We can add negative 98 and 196. And then we get 98 over 16. And at that point, we want to see how many times 16 goes into 98. And it looks like it goes 6 times. And the remainder, 6 times 16 is going to be 96, so the remainder looks like is 2. And we have plus 4, and now we can add the 6 and the 4, and we get 10 and 2/16, which is the same thing as 10 and 1/8. I guess I can just keep going down. So now we have the vertex. Again, I'm not going to show all the math on every single problem because it's just going to get too tedious. There are fast ways that you can do this. I purposely did not do it the fast way just to help you review a little bit of arithmetic, but we're not going to do that again because that just takes way too long. That's why arithmetic is a prerequisite for this course. If you spent all the time just explaining arithmetic, you'd never get done with the intermediate algebra curriculum. So now we're going to find the y-intercept. And to do that, of course, we let x equal 0. And because this is in standard form, this number here is the y-intercept. Remember, that's what this theorem was up here. Okay, so the y-intercept is 4. So we have 0, 4. There's we could show the math on that, but it's just not necessary. Now we're going to find the x-intercepts. And to do that, you let y equal 0. And so I'm going to let y equal 0 in the original equation. And at this point, again, there's a lot of different ways you could solve this equation, but we're going to solve by factoring. And I just want to be clear, I let that 0, I got that 0 from there. And, first of all, when you have a negative on the x squared term, it's easier to factor that out. So I'm going to use the -1 rule, which we covered, I believe, in the previous class. And the reason that works is because if you go backwards, you can see that you just get to the original expression. So now we're just going to kind of ignore that -1, and we're going to factor the expression. So what two numbers multiply to 2? Again, in the previous class, we asked what two numbers multiply to 4 and add up to -7. That's not going to work because we have this coefficient here. So now we have to ask what two numbers multiply to 2, and obviously that's just 2 and 1. And what two numbers multiply to negative 4? Now there are two options for negative 4. It could be 1 times 4, or it could be 2 times 2. We don't know. So I'm going to purposely try something that doesn't work. And by the way, one of them has to be negative and the other has to be positive because we're multiplying to a negative number. And so I'm going to use numbers that don't work because I want you to see that it's okay if you try something and it doesn't work. And again, this is all review, and you might be saying to yourself, you know, if you remember this stuff and you don't think that you need to review this, that's okay. You can just skip forward in the video. But there are some people that may need some review. So what I'm going to do to test this to see if this factorization worked is I'm going to FOIL this out. Remember FOIL, F-O-I-L. Now, it's important to understand that, you know, in the previous problem, we didn't really need to test this factorization to see if it was right, because this was really the only option, this expression here, because 3 only has one option, and it's 3 times 1, and 1 only has one option, negative 1 times negative 1. But in this problem, we're going to have to, you know, we're going to have to test things. So I'm going to purposely try some numbers that don't work. I'm going to try negative 2 and positive 2. Now, they do multiply to negative 4, but when you test this factorization, you're going to find that it actually doesn't work. And to test this factorization, we're going to use the FOIL operation, or the acronym. We're going to do 2x times x is 2x squared. And we don't have to do the whole FOIL. We just have to do O and I. But just to show you, or to help you review the algorithm, I'm going to do the whole thing. And now we do O of FOIL, which is 2x times 2, which is 4x. And then we do I of FOIL, which is negative 2 times x is negative 2x. And then we do L of FOIL, which is negative 2 times 2, which is negative 4. Now, we got 2x squared and we got negative 4. You see, that's a guarantee. We designed the factorization so that would work, you see. So we really don't have to test that part. The part that we're really testing here is the inside part. Do these numbers combine to make negative 7? So 4x minus 2x is positive 2x, so the answer is no, that was not the correct factorization. So if you try something and it doesn't work, that's okay. Just erase it and try something else. So we tried negative 2 and 2, so the other option, if you recall, was 1 and 4. And I believe the 4 is going to be negative and the 1 is going to be positive. Now, if you try FOIL and you get positive 7, that's okay. You just switch the signs. All right. So now let's do FOIL. 2x times x, that's f of FOIL, is 2x squared. Then 2x times negative 4, that's O of FOIL, so that's be negative 8. And I of FOIL is 1 times x, which is x. And then L of FOIL is 1 times negative 4, which is negative 4. Now, if you add these up, you get negative 7x, and that's exactly what we're looking for. Now, don't be confused. We're not looking for this green number up here. That's positive. So what that tells us is our factorization is correct. We have 2x squared minus 7x minus 4. Okay, so now that our factorization is correct, we can now break it up and actually solve. So we know 2x plus 1 has to be 0, or x minus 4 has to be 0, again using the logic that we explained in the previous problem. Now you might be wondering, well, what about the negative 1? Well, that negative 1 doesn't really affect anything. It just kind of hangs out there. So you don't have to worry about it. So x is equal to negative 1/2, or x is equal to 4, and therefore the x-intercepts are negative 1/2, 0, and 4, 0. So let's go ahead and plug that in, or find the intercepts, negative 1/2, 0, and 4, 0. And let's write the y-intercept, which is 0, 4. Whoops. Sorry, sometimes it does that. 0, 4 is here. And the vertex is 1 3/4 and 10 1/8. So 1 3/4 and 10 1/8 is going to be, I believe, about up here. Somewhere around there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's go ahead and show that. We have 1 3/4 and 10 1/8. Alright, now we just have to connect the dots and draw the line of symmetry. And of course write the equation of the line of symmetry, which is x is equal to, I'm just going to write the improper fraction form, 7/4. And there you go. So now it's time for you to try. Go ahead and try problem number 3. And I'm going to leave problem 1 and 2 in the window. And when you come back, we'll do it together. Alright, we're back. So we're going to label constants. Step 1, of course, is to find the vertex. And we're going to use negative b over 2a. There are other ways to do it, but that's just the way that I'm using for these problems. I think it's the easiest way. So we have b and a. And if we simplify that, we get positive 4 over 3, which for graphing purposes we can change that to 1 1/3. Okay, now we're going to find the y value of the vertex. So we're going to plug in the 4/3, the improper form, which is easier to do calculations with. And again, I'm not going to show all the steps for this calculation, because that would just get pretty tedious to have to show that every single time. And again, you should know by now how to do the math. And just to be clear, I'm getting these numbers from here. So let's go ahead and do the math. And you know, I'm gonna skip steps like we did in the first problem. So let's see, we have 16 over 3 minus 32 over 3 plus 4. And so we have a common denominator here, so we can go ahead and combine these two. So we have negative 16 over 3 plus 4. And we want to change this to mixed numbers, so 3 goes in 5 times, and the remainder is 1. And so combining those, we get negative 1 1/3. So the vertex is 1 1/3 and negative 1 1/3. Okay, now let's find the y-intercept. That's the easiest step. If we let x equal 0, then of course this number here is the y-intercept. So our y-intercept is 0, 4. And then we're going to find the x-intercepts. To do that, we're going to let y equal 0. And so we have 3, negative 8, 4. Equals 0. And this is a factorable expression. So I'm going to go ahead and use the factoring method to solve that quadratic equation. And two numbers that multiply to 3 are 3 and 1, and two numbers that multiply to 4 are 1 and, actually they're both going to have to be negative, because you multiply to a positive and add up to a negative, so that means both signs have to be negative. So I'm going to try 1 and 4. And so if we FOIL that out, now I'm just going to do the O and the I of FOIL. So outside is negative 12x, and inside is negative x. So if you combine these, you get negative 13x. Obviously that didn't work, so that's okay. Don't get depressed, just try something different. So what we can do is we can actually switch those numbers before we try 2 and 2. We'll just switch those numbers. Now if we do O of FOIL, we get negative 3x. And if we do I of FOIL, we get negative 4x. Well, guess what? That didn't work either. But again, don't get depressed. Just try something else. Let's try 2 and 2. Pretty sure 2 and 2 has to work. So 3x times negative 2 is negative 6x. And negative 2 times x is negative 2. And add those together, you get negative 8x. You see, sometimes your first factorization doesn't work. That's okay, just try something different. And so now we can go ahead and break it up into two equations. So 3x minus 2 is equal to 0, or x minus 2 is equal to 0. And again, the only reason I'm showing this step is that we have a two-step equation here. It might be kind of confusing for students. So x is equal to 2/3, or x is equal to 2. So that means that our x-intercepts are 2/3, 0, and 2, 0. So there we go, 2, 0, and 2/3, 0. And our vertex is, well, let's do the y-intercept first. That's 0, 4. So I'll be here. And our vertex is 1 1/3 and negative 1 1/3. So 1 1/3 and negative 1 1/3 would be about there. And now we're ready to connect the dots. Again, we could make a more accurate parabola if we plotted more points, but I'm not going to make you do that because that's just more work. As long as you have the main idea. And the equation of the line of symmetry is x is equal to, you can write it as an improper fraction or a mixed number. I don't really care. Okay, so if you got those answers, good job. On to the next problem. So I'm going to leave those in the window, and I want you to try number 4. Number 2 is going to be particularly useful for you when doing number 4, because you see here we have the negative coefficient in front of x squared, and when you get to the factoring part of the problem where you've had to find the x-intercepts, you're going to need to use the -1 rule to make the factoring a lot easier. You don't have to use the -1 rule, but it's going to make it a lot easier. So try number 4, and when you come back, we'll do it together. All right, we're back. So a is equal to -4, b is equal to -7, c is equal to 2, and of course the first step is to find the vertex, and we're going to use vx is equal to -b over 2a, and b is -7, and a is -4. So if we simplify that, it looks like we're going to get -7/8. Now we're going to plug that in to find the y value of the vertex. Okay, and let's go ahead and simplify this expression. Again, this is all stuff you should know. So we get 49 over 64, and that simplifies, when you multiply by -4, it simplifies to -49 over 16, and multiply we get positive 49 over 8 plus 2. Then we need a common denominator. We don't have a common denominator. So we're going to multiply both sides of this fraction by 2 to get 98 over 16. So 16 goes into 49 3 times with a remainder of 1. And if we add those together, we get 5 and 1/16. So the vertex is negative 7/8 and 5 and 1/16. Okay, and now we're going to find the y-intercept. And of course we're going to let x equal 0 to do that. And of course when we let x equal 0, we see that y must be 2. So the y-intercept is 0, 2. And step 3, we're going to find the x-intercepts. In order to do that, we're going to let y equal 0. And plug in 0 to the original equation, negative 4, negative 7, 2. And again, we can solve this in many different ways, but we want to factor, because this is just happens to be a factorable expression, an expression that's easily factorable. But we don't like negatives on the x squared coefficient, so we're going to factor out a negative 1. And what that means is you just have to change the signs of each term. So now we're going to factor, and two numbers that multiply to 4, well, I'm just going to try 2 and 2. I don't really know for sure. Two numbers that multiply to negative 2, there's only one option. It's going to be negative 1 and positive 2, or we might have to switch the signs. And it looks like that's not going to work. So I'm going to try to change these to 4 and 1. And then if we FOIL that out, it looks like that's going to work. So now we have x, we have 4x minus 1 is equal to 0, or x plus 2 is equal to 0. And of course x is going to be equal to 1/4 over here, and x is going to be equal to negative 2 over here, so therefore the x-intercepts are 1/4, 0, and negative 2, 0. That looks right. And the y-intercept is 0, 2. And the vertex is negative 7/8 and 5/16. 1, 2, 3, 4, 5. And now we can just connect the dots. Again, if we plot more points, we get a more accurate graph, but the point of this is not to have perfect graphs. The point is just to get the concepts. And the equation of the line of symmetry is x equals negative 7/8. So if you got that graph, good job. Okay, let's try number 5 together. So we're going to use the same approach. But what you're going to find with this problem is that when you try to find the x-intercepts, this expression is not going to be easily factorable. So first step, as usual, is to find the vertex. And to do that, we're going to use negative b over 2a. b is 3, and a is negative 1. So we end up with 3 over 2, it looks like. And I got that negative 1 from there. and the 3 from there. Okay, so now we're going to plug in 3/2 to the original equation. So we have negative 3/2 squared plus 3 times 3/2 plus 2. And just to be clear, I got that 3/2 from there. So the y value of the vertex is negative 9/4 plus 9/2 plus 2. And we need a common denominator. So I'm going to multiply both sides of this fraction by 2 to get 18/4. And negative 9 plus 18 is 9. And 9/4, if you change that to a mixed number, 4 goes into 9 2 times with a remainder of 1. And so we have 4 1/4. So the vertex is 3/2 and 4 1/4. Next step, we're going to find the y-intercept as usual. So far everything looks the same as the previous problems. We're going to let x equal 0 to find the y-intercept. And of course, when you're in standard form, this number is always the y-intercept. So the y-intercept is 0, 2. So now we're going to find the x-intercepts, and that's where things are going to be quite different. Of course, we're going to let y be 0. And let's copy that equation down, negative 1, 3, 2, negative 1, 3, 2. And so we're going to go ahead and let that y value equal 0. But this expression here is not easily factorable. All quadratic expressions are factorable, but they're not all easily factorable. And so there's two methods that we could use to solve this equation. We could complete the square, or we could use the quadratic formula. But you have to understand that the purpose of the quadratic formula, and that's this formula here, is so to make it so that we don't have to complete the square. Completing the square is a kind of an involved process. We don't want to have to use that, if we don't have to. So we're going to use the quadratic formula. That's the smartest way to do it. So I'm going to try to write that formula a little bit neater. So we have negative b plus or minus root b squared minus 4ac over 2a. And we have a, b, and c. It's up here, a, b, and c. So we just plug those values in. And by the way, you might be thinking, aren't we going to factor out the negative 1? Well, we don't have to do that. We could do that, but we don't have to because we're not really factoring this expression. So I know that gets kind of confusing, but b is going to be 3. And so we're plugging in 3 for b, and then a is going to be negative 1, and c is going to be 2. And of course, we plug in a down here also. So just to be clear what's going on, that negative 1 came from there, and the 3 came from there, and of course the 2 came from there. So now we just have to simplify that expression. So 3 squared is 9, and negative 4 negative 4 times negative 1 times 2, that's just going to be positive 8, and 2 times negative 1 is negative 2. I'm going to put a divider here. So then we're left with negative 3 plus or minus root 17 over negative 2. And I'm going to try to make some more room here by moving some stuff up. Okay, and at this point we have our x-intercepts, but you know, it's kind of hard to understand approximately where these numbers would be on the graph. So what we're going to do is we're going to go ahead and use the calculator. It's going to help us. If you didn't want to use the calculator, then you could just pretend that this number is you know, 16. Then root 16 would be 4. But just to be precise, I'm going to go ahead and enter that into the calculator. So we push the 17, then the square root button, and then we'll add it to negative 3, and then we'll divide that by negative 2. And so one x value is going to be approximately negative 0.56, and the other x value is going to be, push 17 into your iPhone and square root, and in case you didn't understand exactly how to do that, you then push the negative button, the plus or minus button, and then you enter the plus button and then 3, and then push the plus or minus button, and then equals, and then divided by 2, and then the plus or minus button, and then equals. This is all for an iPhone. You know, it's different if you're using an Android. So we have 3.56. And so those are the x-intercepts. And if you want to write the actual coordinates, and by the way, we can change the negatives here to be positive. I know that's going to confuse a lot of people, but that's just going to simplify the expression quite a bit. And the other x-intercept is 3 plus root 17 over 2. Sorry about my writing there. It's very important to understand that we're going to use these as the actual coordinates. We're gonna you know, write those numbers, but we're going to use these numbers to actually try to get a feel for where they are on the graph. So negative 0.56, that's going to be around here, and 3.56, that's going to be about here. So this number is 3 plus root 17 over 2, and the coordinates here are 3 minus root 17 over 2, 0. And now the y-intercept, that's going to be here, and the vertex was 3/2 and 4 1/4. 3/2 and 4 1/4, that's about here. So now, of course, we just connect the dots. And again, I've said it before, I'll say it again, you could make the graph more accurate by plotting more points, but that would take a lot of time. The most important thing is to understand generally how to graph a quadratic expression. And the equation of the line of symmetry, of course, is x equals 3/2. Okay, so that was an example where the x-intercepts were irrational numbers. Remember, we learned that term, irrational. And whenever the x-intercepts are irrational numbers, that means that this expression, this quadratic equation, is not going to be easily factorable. That's why we have irrational x-intercepts, and they're irrational because of that root there, you see. All right, let's try the next problem together, and then you can try 7 and 8 on your own. And so it looks like we're going to get -1 for the vertex. Thankfully, we don't have a fraction. It's good to get away from some of these fractions. Now we're going to find the y value of the vertex. So we're going to plug that in. -1 that should be. And so we have, looks like it's going to be -1. So the vertex is -1, -1. Step 2, we're going to find the y-intercept as usual. And to do that, of course, we let x equal 0, and if we do that, we see that this number here is the y-intercept. So we get 0, 1, and now we're going to find the x-intercepts. To do that, of course, we let y equal 0. So we have 2x squared plus 4x plus 1, 2, 4, 1. Equals 0, and I'm getting that 0 from there. I'm plugging in 0. And what you'll find is that this expression is not easily factorable, so we're going to have to use the quadratic formula. We could complete the square, but you know, why would we do that when we have a nice neat formula to use? That was the whole purpose of deriving this formula, is so we wouldn't have to complete the square. Completing the square is a involved process. Okay, so B is 4, and A is 2, and C is 1. So simplifying, B squared is 16, and then -4 times 2 times 1, that's just going to be -8, and 2 times 2 is 4. So if we simplify, obviously we're out of room, so I'm going to use an arrow to go up here. We have -4 plus or minus √8 over 4, looks like. Here's an example where we can simplify this root here. Now in the previous problem we didn't have to do that. We couldn't do anything with √17. But we really need to simplify this. Mathematicians don't like it when you leave a perfect square factor inside a root. To make things simpler, we're going to change this to 2√2. Now you may say, well, how did you do that? Well, that's why we had about 4 classes, I can't remember, 4 or 5 classes on square roots, so that you would know how to do this. If you need to review that, you can go back to those courses, or those classes in this course on roots. Now at this point we need to do another dirty trick. We need to reduce this fraction. We have numbers in this term, and this term that have common factors. So we can divide both sides of the fraction by 2, and we get -2 plus or minus √2 over 2. 2 divided by 2 is 1, -4 divided by 2 is -2, and 4 divided by 2 is 2. Okay, so now we have our x-intercepts, but we don't know what that number looks like. So it's going to be useful to enter that into our calculator. So I'm going to push the 2 button, and then the square root button, and then +2, and then the plus minus button equals, and then divided by 2 equals. And I get -0.292. Or x is equal to, I'm going to push the 2 button, then the square root button, and then I'm going to push the plus minus button to change it to negative, then +2 and the plus minus button to change it to negative, and then equals, and then divided by 2 equals, and we get -1.7. So -1.7. So again, our x-intercepts, they're just going to be -2 plus √2 over 2, 0, and -2 minus √2 over 2, 0. But we can't, I mean, we're going to use those numbers, but we can't really we don't really know what exactly that's going to be. That's why we approximated with those decimals. Okay, so let's plot those negative 0.29. That's going to be about here, and negative 1.7. That's going to be about here. And we're going to have to write those big expressions, so negative 2 plus root 2 over 2, 0. And the other point is going to be negative 2 minus root 2 over 2, 0. And the y-intercept is 0, 1. And the vertex is negative 1, negative 1. So it'll be here. And now we just connect the dots. And of course, draw the line of symmetry. And our equation is going to be x equals negative 1. Okay, so I'm going to leave problem 5 and problem 6 in the window, and I want you to try number 7. So go ahead and try number 7, and when you come back, we'll do it together. All right, we're back. So let's label constants as usual. And it looks like we're going to end up with 5 over 6. And the y value of the vertex, we're just going to plug in the x value into the equation. So we get 3 times 5 6 squared minus 5 times 5 6 minus 3. And just to be clear, I got that number from there as usual. We get 25 over 12 minus 25 over 6 minus 3. We need to get a common denominator. Multiply both sides of this fraction by 2, and we get 50 over 12. Then combine. 25 minus 50 is negative 25. And 12 goes in 2 times. So we're going to have negative 2. And it looks like there's going to be a remainder of 1. And combining those, we get negative 5 and 1/12. I know these fractions are very tedious, but you're just going to have to deal with them. So the vertex is 5 6 and negative 5 and 1/12. So now we're going to find the y-intercept by letting x equal 0. And whoops, I forgot to write this step. That's step number 2. And of course, if we let x equal 0 in a standard form quadratic, then this number here is always the y-intercept. So the y-intercept is 0, negative 3. And step 3, we're going to find the x-intercepts. And to do that, of course, we let y equal 0. So we go up into the original equation and let y equal 0. And so just to be clear, that 0 came from there. And this is an equation that is not easily factorable, so we're going to use the quadratic formula. And then we just have to plug in numbers. So b is negative 5. And please be sure to use parentheses in this negative 5 here when you're squaring it. And c is negative 3. so now we just have to simplify that expression. A double negative becomes a positive, obviously, and negative 5 squared is 25, and then we get plus 36 over 6. And let me write a divider here. And so x is equal to 5 plus or minus root 61 over 6. Now we need some approximations, so we have a reference to know where to write the x-intercepts on the graph. So I'm going to use my computer calculator, and I'm going to write 61 square root button, then plus 5 equals, then divided by 6 equals. There may be different ways to write it in your calculator, or enter it into your calculator, but that's just the way that I do it. And for the other number, we now need 61, then the square root button. Then we're going to change it to a negative by pushing the plus minus button at the bottom left. Then we're going to add 5 equals, then divided by 6 equals a negative 0.468. So negative 0.468. So now we have a reference for the graph, but we're not going to write those numbers on the graph. We're going to write 5 plus root 61 over 6, 0, because that's an exact number, and 5 minus root 61 over 6, 0. And so let's go ahead and graph those x-intercepts. 2.13 is about here, and negative 0.468 is about here. So this would be 5 minus root 61 over 6, 0. And this would be 5 plus root 61 over 6, 0. The y-intercept is going to be 0, negative 3. And the vertex is 5, 6, and negative 5 and 1, 12. 1, 2, 3, 4, 5 is going to be about here. And now we just have to connect the dots. And again, you could make a more accurate graph if we plotted more points, but I'm not going to make you do that. Then draw the line of symmetry. And write its equation. Okay, so if you got that graph, good job. On to the next problem. I want you to try number 8, and I'm going to leave the previous problems in the window. So go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. So let's label constants. And it looks like we're going to get negative 1 for the vertex. And of course, to find the y value of the vertex, we just plug in the x value of the vertex to the original equation. Okay, now let's simplify. Looks like we're going to get 6. So the vertex is negative 1, 6. And now we're ready to find the y-intercept. And of course we let x equal 0, and the y-intercept is just going to be 0, 5. I know you're tired of hearing me say this, but in standard form that number is always the y-intercept. Now we're going to find the x-intercepts. To do that, of course, we let y equal 0. So we have negative 1, negative 2, 5. And we have to solve this quadratic equation, but it's not easily factorable, so we're going to have to use the quadratic formula. And it's good to have to write this formula again and again and again, because that helps you remember. So now we're just going to plug in the values. We have negative b plus or minus root b squared minus 4 times a times c all over 2 times a. And just to be clear, I got the a from there, and I got the b from here, and I got the c from here. Okay, so now we just have to simplify. So the double negative there becomes positive, and negative 2 squared is 4, and negative 4 times negative 1 is positive 4, times 5 is 20, and 2 times negative 1 is negative 2. And so we're going to add that up in the inside of the root, but it looks like we're out of room, so I'm going to go up here. So we have 2 plus or minus root 24 all over negative 2. So I know it's kind of annoying to have to deal with this, but you've got to pull the perfect square out of that root. Mathematicians don't like perfect square factors inside roots. So 24 is 4 times 6. The 4 comes out as a 2. The 6 stays in. Again, that's all stuff that we learned in my root classes. Now we can divide each one of these terms by 2. And if we do that, we get 1 plus or minus root 6 over negative 1. And of course that simplifies. When you divide a polynomial by a monomial, you just switch the signs, and this might be a little weird. I'm sorry I gave you this problem because you may have had a few issues here, but that's going to change the 1 to a negative, and the plus and minus, it's not really going to affect it, because if root 6 is positive, then it would change to negative, but that's already an option. It's already plus or negative. If this is a negative, then dividing by a negative would change to a positive, but positive is already an option. So I know it's kind of strange, but this is the only number that really changes. So now x can be approximately, and we can use the calculator, or we can just pretend that 6 is a 4, or 6 is a 9, something around there. But just for explanation purpose, let's go ahead and use the calculator. So 6 and then the root button, and then plus 1, and then the plus minus button equals if you're using an iPhone. So we have 1.4, approximately 1.4, or x is approximately, if we push 6, then the root button, square root button, and then the plus minus button, and then plus 1, and then the plus minus button again, and we get negative 3.44. And so that just gives us a reference for the graph, but our x-intercepts are going to be negative 1 plus root 6, 0, and negative 1 minus root 6, 0. Okay, so 1.44, that would be about here, and negative 3.44, that would be about here. So we have negative 1 plus root 6, 0, and we have negative 1 minus root 6, 0. And the y-intercept is 0, 5. And the vertex is negative 1, 6. Should be about here. And now we can just connect the dots. I'm going to have to move those coordinates over. Okay, and now we just have to draw the line of symmetry and write its equation. So the line of symmetry is going to be x is equal to -1. So again, I'm sorry if I confuse you with this this weird stuff here, but in all fairness, you've seen that before in my previous classes where we solved quadratic equations with a quadratic formula. So if you got that answer, good job. And by the way, this is a little bit off here. Again, it doesn't have to be perfect, but that graph really should have been going through this point here. You know, try to make it as accurate as possible. It doesn't have to be perfect. Okay, so we have two more problems. Now these problems are going to be, we're going to have a situation where there are no x-intercepts. And you're going to see what it looks like when you solve a quadratic expression that doesn't have any real solutions. So we're labeling constants. And the first step, as usual, is to find the vertex. And looks like it's going to be -3. And the y value of the vertex, we use the x value of the vertex in the original equation. And we get -3 squared plus 6 times -3 plus 10. And just to be clear, I'm getting that -3 from here. And of course, I'm getting the 1 from there and the 6 from there. All right, and so now we have 9 minus 18 plus 10. And then we get 1. So the vertex is -3, 1. Now, the y-intercept. So everything seems normal so far. Of course, we let x equal 0 to find the y-intercept, and when we do that, the y-intercept has to be that number there. So our y-intercept is 0, 10. In step 3, we're going to find the x-intercepts. And to do that, of course, we let y equal 0. And so we get 0 is equal to x squared plus 6x plus 10. This is not, it's not factorable, or it's not easily factorable, so we're going to have to use the quadratic formula. And just to be clear, we're plugging in 0 for y. So now we just simplify, and we have x is equal to -6 plus or minus root 36 minus 40 over 2. And obviously we're out of room, so we're going to go up here and continue to simplify. So x is equal to -6 plus or minus root -4, and that should throw up a red flag because we have a negative inside the root. And that's what I meant when I said that this quadratic expression, when you graph it, it doesn't have any x-intercepts. Because when we try to find the x-intercepts, we see that the solutions are imaginary. Now, at this point, you can really stop. You don't have to keep going. You know, in fact, I might just put a stop there just to remind you that you don't really have to keep going. But I'm just going to keep going just to show you what's going to happen. So remember, a square root -4 just becomes 2i, and if you want review on that, you can go to my, I think it's the some of the last classes on my roots, on the roots subject. And so now we can just reduce that, divide everything by 2, and we get -3 plus or minus I. And so we have two solutions, -3 plus I and -3 minus I. But again, these are not real numbers, so they don't appear on an xy plane. But again, I only did this work here to show you what happens when there are no x-intercepts. You're always going to get an I, a negative under the root, when there are no x-intercepts. So we can't really graph x-intercepts because they're not there, but we can graph the y-intercept. It's going to be all the way up here. That's 0, 10. And the vertex is negative 3, 1. So 1, 2, 3, 1. And those are really the only 2 points that we found so far. So we're going to have to use symmetry. We're going to have to go out 1, 2, 3 to the left and up to that point. And I'm not going to make you label that point, but again, just to make the parabola look right, we're using that reference point. And of course, this was negative 3, 1. And now we just have to draw the line of symmetry and write its equation. X is equal to negative 3. Okay, so that's what happens when there are no x-intercepts. Why don't you try, and again, you can stop when you get to this point. You don't have to really go any further. You can, there's not going to be any x-intercepts. But I do want you to do this work here just to show you what it looks like when you have no x-intercepts. So go ahead and try number 10. I'm going to leave number 9 in the window, and when you come back, we'll do it together. All right, we're back. Step 1, of course, we're going to find the vertex, and we have negative b over 2a. B is 4, and a is negative 2. So it looks like we're going to have 1 for the x value of the vertex, and the y value of the vertex. We're just going to plug the x value of the vertex into the original equation to find it. And we get negative 2 times 1 squared plus 4 times 1 minus 3. And now we just simplify that. Negative 2 plus 4 is 2, minus 3 is negative 1. So the vertex is 1, negative 1. Step 2, we're going to find the y-intercept. And of course, we let x equal 0. And we see the y-intercept has to be 0, negative 3, because negative 3 is up here, you see. And for the x-intercepts, we're going to let y equal 0. So we have negative 2 for negative 3. Is equal to 0. Letting y equal 0. And so now we're going to have to solve this quadratic equation, but you'll find that it's not easily factorable, so we're going to use the quadratic formula. And then we're just going to plug in values. So b is 4, and a is negative 2, and c is negative 3. So now we're just going to simplify that. And negative 4 times negative 2 is positive 8, and then positive 8 times negative 3 is negative 24, and you can see there's a red flag there because we're going to have a negative inside the root. But let's just go ahead and calculate what that would be inside the root before we stop. So it looks like we're going to get 16 minus 24 is negative 8. And on the bottom we have negative 4. So at that point we can stop because we know that if there's a negative inside the root, that means there are no x-intercepts. So let's plot the y-intercept, 0, negative 3. And the vertex is 1, negative 1. And So those are really the only points. So we're going to use a reference point here and connect the dots. So if you got that graph, good job. Let's draw the line of symmetry and write the equation of the line of symmetry, which is x equals 1. So that was the class today. Again, this is just another example of a parabola that does not go through the x-intercept, and the expression itself is not factorable, so we can't see that it doesn't go through the x-intercept unless we solved and use the quadratic formula. Now there's actually an easier way to do it. I mean, once we find the vertex and we know that from this negative coefficient on the x squared term that's going down, we know that there's not going to be any x-intercepts, but I just wanted you to see what it looks like when you try to solve and there's no solution to the equation because there are no x-intercepts. Okay, so that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and screenshot number 2 and screenshot number 3 and screenshot number 4 and number 5 and number 6. Don't go before you get your homework. Let's take a look at the homework. Here's the homework. Take a screenshot of these first 2 pages and the 3rd and 4th page. Remember, your homework has to be complete, correct, neat, and in correct chronological order in your binder. And if you don't do that homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.